Alright guys, so on activity 4-1, we're really starting to talk about exponential functions. And the generic equation for an exponential function is going to be f of x equals a times b to the power of x. The thing that's really important here is that your x is actually in the exponent. So for it to be an exponential function, your variable, or the thing that's going to change, is going to be in your exponent. In 4-1 in Springboard, we actually talk more about consumer mathematics. And within the consumer mathematics, the first formula we're going to use is right here. A of t equals p times 1 plus r divided by n, all to the power of nt. A of t stands for the amount of time, the amount that you're going to have after the time t. The p is your principal, or your starting amount. How much do you start with? Your R is your rate. Normally with these, it's going to be an interest rate. You have to be careful of the word depreciation, though, because depreciation will actually make your interest rate negative. N, in this case, is going to be the number of times compounded yearly. N is given to you in terms of a word. So over here I have some keywords like annual. Annual means that my N is going to equal 1. Semi-annual, the N would be 2. Monthly, my N would be 12. Weekly, of course, N is going to be 52 weeks in a year. And then daily, my N would be like 356. Now I can ask you other things like quarterly. It's going to be words that you've already recognized. It's going to be able to relate to a number, and that's what your N is going to be. And of course, T stands for time, in this case, in years. In Springboard, they talk about how Margaret won the lottery, and she has $50,000 she's going to initially deposit. And so when we go in here and do this, we're going to identify our parts. It says that it compounds annually, so my N is going to equal 1. My P was going to be her first initial value of $50,000. And we're going to figure out that T, we're going to figure out how much money she's going to have in her account after 10 years. And her rate, they said, was 5%. So my R is 5%. And if you remember how to convert percents to decimals, you can just move the decimal 2 places to be 0.05. Or you can just do 5 divided by 100, which will also give you 0.05. From here, we just plug it into our equation. This becomes nothing more than plug and chug. We are going to get A of t equals 50,000 times 1 plus my R, which is 0.05, divided by 1 times 10. We'll clean this up a little bit. We get 50,000, 1.05, once we do all the arithmetic inside the parentheses, and of course 1 times 10 is just 10. When we do this, we are going to get $81,444.73. Now, I will never ask you, or actually will never tell you in a word problem when it deals with money where to round to. You must know to round to the nearest penny. Do not round to the nearest dollar, not the nearest quarter, not the nearest nickel. It must be to the nearest dollar. Another type of problem that they're going to ask you on is going to be something along the lines of, if Margaret, if we look back at 7b in the problem itself, it wants to know how long it takes her to double her money. So she still has a P, which is 50,000. In this case, my A of t, the amount that I'm going to have after time t, is going to be double that, which is going to be 100,000. My rate is still 5%, which would be 0.05. And of course, my N is still compounding annually is 1. So we're going to use the formula. We're going to set it up. The formula being A of t equals P to 1 plus R divided by N and T. We're going to plug everything in. We know my A of t, that is 100,000. We know my P, that is 50,000. Times 1 plus my rate is 0.05. My N is 1. And of course, 1 times T. We don't know what T is yet. Here, we'll just kind of clean this up. I'm going to divide by 50,000, so I'm going to get 2 equals 1.05t. Now, this is an exponential function because my variable is in the exponent. I need to solve for that. So we have to do the inverse operation of the exponent, which is logarithms. In this case, I'm just going to use log base 10. It is an operator, so you need to do it on both sides of your equation. What's nice about this is with your exponent, you can now bring it down in front. So I'm going to get log 2 equals t log of 1.05. This is a number. Log 2 is a number. So to get t by itself, I divide by the entire log of 1.05. Therefore, t equals log of 2 divided by log of 1.05. When you throw that in the calculator, you get about 14.21 years. That's how long it's going to take her for her money to double. But in context of the question, it's going to actually ask you how long does it take to actually double her money. Well, in year 14, she does not have $100,000 yet. So you actually need to go to year 15 where she'll have more than $100,000. So we would actually take what we call the ceiling of this function, of this answer. So my time would actually be 15 years. Now in future videos, we're going to go over when we have compounding continuously. We're going to learn a formula that it's easy to remember. I just call it PERT. And then we'll do some more practice. We'll do some practice problems where when our n is not just 1, when we can have n is 4, when we have n is 12. And we'll actually discover something about when it's continuous versus if we decided I want to make you figure something compounded continuously by the second.